And no one said anything.
Oh, hi, Sebastian.
Hi, Sebastian.
All right, so we're just going to do some examples today, and then you'll have a worksheet for your assignment. So here, tell what method, if any, can be used to prove the triangle's congruent. So this is just a chance for you to not have to do the entire proof. You're just going to mark what's given, add anything that you know you can add to the diagram, say how you would prove the triangle's congruent. It's a lot shorter than having to do an entire proof. So here, segment KY is congruent to segment RA, and then AK is perpendicular to KY, so I know that that's got to be a right angle. And AR perpendicular to YR, that means angle R is a right angle. I can also add that segment AY is congruent to itself by the reflexive property. So what method could I use to prove these two triangles congruent to one another? Hypotenuse leg, exactly right. It's a right triangle. That doesn't necessarily make it hypotenuse leg, but it's not angle side angle or angle angle side or any of the other ones. So it's going to be hypotenuse leg. For number 2, it says M is the midpoint of JE. So JM congruent to segment ME. JE is perpendicular to segment JA. I left off the segment symbol on both of these. I guess I'll go straight to geometry hell then. So this is a right angle, and angle E will be a right angle. What else do we know from the diagram? Because? Yeah, I know the vertical angles are congruent. And now I'll go ahead and say, oh, well, I'm going to use the right angles are congruent. Because I don't have hypotenuse leg, I have angle side angle. And you'll see these letters a fair bit. This is my daughter, this is my son.
Huh?
Pardon?
What?
This spells James, this spells Kira.
Oh.
This is my daughter, rectangle. This is my son, two triangle.
See if you get this one.
Hello. Cougar.
Yeah, like, you know, Northland. Wow. Just remember, he who laughs last thinks slowest.
Yes.
You left off. Yeah, he did laugh last.
So we'll have our statements and our reasons. I do all the given at once. Most students do as well. So here we have an angle bisector. Be sure you're bisecting the correct angle. It's bisecting angle OUG. So the vertex is at U. So it's the two angles down here that are congruent to one another, not the two at the top. Occasionally students read that too fast and they don't pay attention and it messes everything up. So angle OUC is congruent to angle GUC by the definition of angle bisector. Then I've got some perpendicular lines. What do perpendicular lines make? right angles where they meet. CO and OU meet at O, and fortunately, it's the only angle at O. And likewise over here, this is the only angle at G, so I can say angle O and angle G are right angles by the definition of perpendicular lines. Whenever we have right angles in one of these proofs, we're going to have to decide, am I going to end up using hypotenuse leg, or I'm going to use anything else? If I have hypotenuse leg, I have to say that I have right triangles. If I'm using anything else, I have to say that the right angles are congruent. I have had students in the past who do both, and they're like, that way I'm covered. And while I can appreciate that, I'm too lazy to do that. So which is it going to be? Is this going to be hypotenuse leg, or is it going to be something else? Oh, I heard both.
Well, because the right angles, they point at the hypotenuse is right there.
So we're going to be able to prove the hypotenuse is congruent, but what about the legs?
Because I marked it originally with the legs as congruent and not the angles.
Gotcha. Okay. So it's going to be something else. So we'll go ahead and say that those two angles are congruent. If you're not sure, you can delay that. You can say it later. So this is all right angles are congruent. Now we can do what Lexi was talking about. Go ahead and say that CU is congruent to CU by the reflexive property. That's enough to prove the triangle's congruent now. Generally, once I have 3 pairs of parts, I have enough. Not always, but generally. I can name the first triangle any way I want. I'm going to call it triangle COU. But once I've done that, I've got to name the second one so that the corresponding parts match up. How should I name the other one? What? Yep, CGU. And by what reason? Angle, angle, side. And then, if the triangles are congruent, then any corresponding parts will be congruent. So CO is congruent to segment CG by the definition of congruent triangles. Any questions about that proof? Yes, ma'am. I thought you had a question.
Oh, no, it was like that.
I don't know what that means.
No.
Okay. Let's take a look at this one. All right. We're going to have to make some decisions here about exactly what we do. By the way, it looks like there's a segment from M to Q. There is not. There is no segment drawn from M to Q. I unfortunately used a blue pen when I drew this, and so the line that I used to help line it up makes it look like there's another line there, but there's not. So MN is congruent to QP, and angle MNP is congruent to angle QPN. part of what we have to do on this is decide which triangles we're going to try to prove congruent. There are 5 triangles in this picture. Do you see them? It's a little hard at first to see all 5 of them. Most people see the 3 little ones pretty quickly. This triangle, this triangle, this triangle, but then there's also triangle MNP and QPN. Now, I'm trying to prove angle M congruent to angle Q. Well, if I could prove these two, we always just call them butterfly wing ones like this. If I could prove those 2 triangles congruent, I could prove angle M congruent to angle Q, right? Or if I proved triangle MNP congruent to QPN, those 2 big ones, I could prove M congruent to Q. So what you're trying to prove doesn't help you in this particular case. Sometimes it will. Sometimes you look at what you're trying to prove and you're like, well, that tells me those are only in these 2 triangles. But in this case, it doesn't. So we still have to decide, and there's a couple of things that decide to you on this one. First of all, they gave you that this whole angle is congruent to this whole angle. If they were trying to prove the littler triangles congruent, it would be just this piece up here and just this piece up here. The other thing is that they didn't give you a letter for this point. Makes it really hard to try and prove these 2 triangles congruent if you don't have a name for that point. So we're trying to prove triangle MNP congruent to triangle QPN. And you're like, okay, well, they gave me a couple of things congruent, but they didn't give me anything else. So there must be something in the diagram that I can use, and it's not the vertical angles because I don't want to prove those 2 little triangles congruent. Does anyone see it? I'm sorry? Yeah. Both triangles have segment NP as one of their sides. So instead of them being back to back like it's been in most of our diagrams, here these 2 triangles overlap each other. So segment NP is congruent to segment NP by the reflexive property. Now we have enough to prove those 2 triangles congruent. I've got 3 congruent things. I've got 2 sides and an angle in between them in both triangles. So triangle, I can name the first one any way I like. I'm going to call it MNP. I got to make the corresponding parts go together. I really want M to correspond with Q. Is it QNP or QPN? Why? Oh, sorry, a little louder. The ACs are going.
Because MN congruent to QP.
Yeah, MN is congruent to QP, so I want MN and QP to match one another. Exactly. Okay, I've got to have the corresponding parts matched up. This is side angle side.
Wait, is it an angle or a triangle? Because you put
Oh,
triangle.
sorry. I was talking too much and not concentrating on what I was writing. Thank you. So now angle M is congruent to angle Q by the definition of congruent triangles. Any questions? Okay.